Hi and good afternoon, boys and girls. Here with you is Teacher Regan. Once again, welcome to Easy Elimu, Learning Simplified. So in our previous sessions, we have been discussing whole numbers. And under whole numbers, we discussed the operations. We have discussed quite a lot of things. So our next substrand under the main strand of numbers is factors. So under factors, we are going to start with the divisibility test rules. But before then, I need to clear something here. Most of us normally tend to confuse between factors and multiples. For example, when you are asked to state the factors of 9. This is different from the multiples of 9. For example, 9 is equal to 1. The first factor of 9, factors are those numbers that can divide 9. The first factor of 9 is 1, second factor of 9 is 3, and the third factor of 9 is 9, which is the number itself. What about multiples of 9? Multiples of 9. Multiples of 9 are all those products that we can get by multiplying 9 by all the possible numbers that are there. For example, the first multiple of 9 is 9, which is 9 times 1. The second multiple of 9 is 18, which is 9 times 2. The third multiple of 9 is 27, which is 9 times 3. So kindly take note of the difference between factors and multiples. Factors are those numbers that can actually divide a given number, while multiples are the list of products that can obtain by multiplying a given number by different other numbers. So that clarified, we can now start. So we have divisibility test rules. What are divisibility test rules? And what is the essence of discussing the divisibility test rules? Primarily, the essence of coming up with this divisibility test rule is to simplify our problem-solving steps, especially whenever you are working with division. At times, you have to divide a very big number by a very small number, or rather, you have a very big dividend to be divided by a very small divisor. In that scenario, your concept in the divisibility test rules will be very, very essential. So in our today's session, we are going to discuss the divisibility test rule of the first three numbers. That is 2, 3, and 4. So we are going to discuss the divisibility test rule of 2, 3, and 4. So we are going to define the divisibility test rule of a given number, see an example, and discuss how to answer the questions regarding the same. So let us start with the divisibility 1.1, divisibility test rule of 2. Divisibility test rule of 2. Someone to try. How do you know if a number is divisible by 2 without a remainder? Without going into the nitty-gritty of manually dividing that particular number. How can you know if a given number is divisible by 2 without a remainder? Yes, any trial? Correct. So rule, you can write rule. A number is divisible by 2. A number is divisible by 2, underline that 2, if the digit in the ones place value is 0, 2 itself, 4, 6, or 8. So given any number and you want to determine whether that particular number is divisible by 2, then all your focus should be channeled towards the digit in the ones place value. Ignore. It can be a billion. It can be a number to the tune of hundreds of millions, and you are asked to decide whether that particular number is divisible by 2. Then all you have to do is to look at the digit in the ones place value. If that digit is either 0, 2, 4, 6 or 8, then you can authoritatively conclude that that particular number is divisible by 2. Example. Which of the following numbers are divisible by 2? So in this question, in order to answer this question properly, you consider the digits in the ones place value in both numbers. So here the first number, 336. What is the digit in the ones place value? Yes, Paul? 6, correct. So the digit in the ones place value in the first number is 6. And the second number, which is 445, the digit in the ones place value is 5. So we said, for us to decide whether a number is divisible by 2, then the digit in the ones place value must be 0, 2 itself, 4, 6, or 8. And here we have the number 6 and the number 5. So in the first instance, the digit in the ones place value is 6, and in the second instance, the digit in the ones place value is 5. And 5 is not among the given digits. Therefore, you can say 336 is divisible by 2 because the digit in the ones place value is 6. That is how you answer the questions on the divisibility test rule. Do not do manual division of each of the numbers. If you do that, you are not using the divisibility test rule, but rather you are going about it like someone who has never heard of the divisibility test rule. So from there, let us go to the divisibility test rule of 3. Divisibility test rule of 3. Divisibility test rule of 3. So I'll just change here. The divisibility test rule of 3. How do we know if a given number is divisible by 3? How do we know if a given number is divisible by 3? So rule. Anyone who can try? All right. So we can say a number is divisible by 3. A number is divisible by 3 if the sum of its individual digits is a multiple of 3, or divisible by 3. For example, you can say, for example, you can say a number like 3,102 is divisible by 3 because the sum of its individual digits is a multiple of 3, or rather divisible by 3. i.e., that is, so we have the number 3102. So we want to confirm whether this number is divisible by 3. And we have said that a number is divisible by 3 if the sum of its individual digits is a multiple of 3 and O is divisible by 3. So here we shall get the sum of the individual digits, which is 3 plus 1 plus 0 plus 2. What do you get? 3 plus 1, 4 plus 0, 4 plus 2, 6. 6 is a multiple of 3. Which multiple of 3? The second multiple of 3. So since 6 and 6 is actually divisible by 3. So that is why we are saying that that particular number is divisible by 3. Another example. Prove that 336 is divisible by 3. So most students normally make a mistake of dividing this number by 3. When you are asked to prove whether a certain number is divisible by a given number, in this case, we are supposed to prove whether 336 is divisible by 3. You are supposed to show that proof by applying the divisibility test rule. So you can alternatively define or state the divisibility test rule, or rather, you can go ahead and perform it. So solution. Now that we know the divisibility test rule of 3, which states that a number, that is 336, can only be divisible by 3 if and only if the sum of its individual digits is a multiple of 3. So we can show that by taking 3 plus 3 plus 6. That is 3 plus 3, 6 plus 6, that is 12. And 12 divided by 3, 12 divided by 3 is 4. Then you say 336 is divisible by 3, because the sum of its individual digits is divisible by 3, or rather a multiple of 3. That is how to prove that a number is divisible by a certain number. You use the divisibility test rule. After that, let us discuss the divisibility test rule of 4. Then I'll give you some questions on the same. Any question? So all you need to do is to conceptualize the divisibility test rule of a given digit. Once you have done that, then know how to apply the same rule. Once you are good in that, then you're good to go. Let's discuss now the divisibility test rule of 4. How do you know if a number is divisible by 4 without going through the usual steps of division, or rather by using the rule? Divisibility test rule 4. So, having discussed the divisibility test rule of 2, divisibility test rule of 3, now let us talk about the divisibility test rule of 4. Then after that, I can give you some questions for you to be able to retain your understanding in the same area. So, straight away, let us state the rule. So, a number is divisible by 4, a number is divisible by 4 if the number formed by the digits in tens and ones place value is a multiple of 4. So a number can only be divisible by 4 if and only if the digit, or if and only if the number that is formed by the digits in the tens and ones place value is a multiple of 4. For example, we can have an example like, for example, right there, for example, 1024, or rather 1024 is divisible by 4, allow me to write there, is divisible by 4 because the number formed by the digits in the ones, not really, by the digits in the tens and ones place value is a multiple of 4 and or divisible by 4. As shown below, for example, our number here is 1024. Kindly let us identify the digits in the tens place value. Yes, Emily? What's the digit in the tens place value? 2, correct. So the digit in the tens place value is 2 and the digit in the ones place value is 4. So the number that is formed by these two digits is 24. And 24 is a multiple of 4, or rather 24 is divisible by 4. So if that is the case, then the whole of that number, irrespective of the size of the number, we can say that a number is divisible by 4. It can be 1 million so long as the last two-digit number is a multiple of 4, then you can authoritatively say that that particular number is divisible by 4. Any question? If there is no question, then I can give you some few questions testing on the first 3 divisibility test rules. Questions. Number 1, which of the following numbers are divisible by both 2 and 4? Use divisibility test rule. So part A, we have 1138. Part B, we have 29364. Part C, we have 4908. Part D, we have 1146. And number 2, show that or prove that the following numbers are divisible by 3. So part A, we have 1, 1, 1. Part B, we have 33,000. 666. That's 3,666. Part C, we have 31,026. So prove, in the first instance, you're supposed to group the numbers that are both divisible by 2 and 4. And in both cases, you're supposed to use the divisibility test rule. Do not use manual division method. If you use that, whether your answer is right or wrong, but since you didn't apply the right method, we shall assume you are wrong. Otherwise, that marks the end of our session today on the divisibility test rule of 2, 3, and 4. See you next time.